series organized by KSCSTE National Transportation Planning and Research. This talk series is yet another unique venture of NATPAC designed to explore diverse topics from the cutting-edge technologies to sustainable solutions. Here, we will be featuring eminent young researchers to share their valuable insight for kindling the spirit of future research and development in transportation. Today, we have with us Dr. Donia Savio, Senior Research Fellow, Department of Civil Engineering, Indian Institute of Technology Madras, for sharing her valuable insights on the topic, influence of braking maneuvers on the reliability of bituminous pavements. Now, I request Sri Jagan Bharat Kumar A, scientist, to deliver the welcome address.
Good morning all. KSCSTE-NATPAC has initiated the Transpedia Research Talk Series, a technical discussion series that is designed to encourage research for shared benefit by disseminating knowledge on a wide range of topics, including sustainable solutions and cutting-edge technologies. Fortunately, this also provides a platform for young researchers from world to network and engage in order to better influence the future of transportation research and development. The very first lecture of the series was placed on 24th August 2023 through an online platform with over 200 participants from distinguished universities and departments in participation. The inaugural speech was presented by Professor Dr. Tom B. Matthew, Chairman of Research Council of KSST-NATPAC and Professor at IIT Bombay. A diverse range of topics in transportation engineering has been addressed in approximately 17 sessions that have been effectively conducted over the past year and a half. Today, the 18th talk in this series will be delivered by Dr. Donia Savio, Senior Research Fellow, Indian Institute of Technology Madras. I extend a cordial welcome to our distinguished speaker who has gracefully accepted our invitation to share knowledge and perspective on the topic of influence of braking manuals on the reliability of bituminous pavements with great pleasure and enthusiasm. After the presentation, we will have an interaction session where you can pose your questions and engage in a meaningful dialogue with Dr. Donia. Feel free to participate actively. Once again, thank you for being here today, and let us give a warmest welcome to Dr. Donia Savio as we eagerly await the insight she is about to share.
Thank you, sir, for your welcome note. Now, I would like to invite Dr. Gautam Sarang, Junior Scientist, to introduce the speaker to the audience.
Thank you, Akrin. A very good morning, honorable present here. So today we have Dr. Donia Savio to present the 18th Transpedia Research Talk. So Dr. Donia completed her PhD from IIT Madras in the year 2023 under the supervision of Professor Dr. J. Murali Krishnan on the topic influence of axle load distributions and vehicle maneuvers on the reliability of bituminous pavements. She was one among the awardees of Women Leading IITM in 2022, which is an award given to exceptionally talented women researchers in IIT Madras. Her 6 research papers were published in reputed international journals, and she also has 2 conference papers and a book chapter in her credit. Dr. Donia is currently working as a senior research fellow at IIT Madras in an Indian Army funded project for enhancing the runway pavement design methodologies used in Indian military airport infrastructure. Now let's hear from Donia. Thank you.
Thank you, sir, for the introduction. Now I invite our distinguished speaker to deliver the talk. Over to you, ma'am.
First of all, thank you for giving me this opportunity to present my research work. So in the NATPAC, NATPAC platform, and thank you so much, especially my senior, Dr. Anila, for giving me this opportunity. So now I'll be presenting my topic. I think you can see the slides.
Yeah, it's visible.
Okay. So I am going to present a part of my research work on the topic influence of braking maneuvers on the reliability of bituminous pavements. And this is the overview, this is the outline that I'll be following in this talk. So I'll be first giving an overview of my work, then about the braking maneuver, what happens during braking, what are the loads that are transferred from the tire to the pavement during braking maneuver, and what all are the the wheel locking conditions. In that case, how much is the load transfer and associated things I will be explaining, and then about the influence of such loads in the estimation of reliability, what kind of a framework I have formulated, and all such things, details I will be showing in this talk. Now, coming to the overview of my work. So, as you all know that one of the most critical input for pavement analysis and design is the axle load data and is associated with uncertainty. So, usually we collect axle load data from the field using different methodologies. So in India, we use either the static pressure pads, like the axle load pressure pads, using which we can collect the static axle load data. We use also weigh in motion systems to collect the data, and even vehicle dynamic softwares are available to simulate the loads. That is especially the dynamic loads. Why we wanted to use that? Because the actual loads that are transferred from the tire to the pavement is dynamic in nature and it is not static always. So what all are the factors that influence the load that is transferred from the tire to the pavement? They are the vehicle maneuvers, the road roughness, and the vehicle suspension systems. So coming to the vehicle maneuvers. So if a vehicle is moving in a constant speed, mostly the load that is transferred from the tire to the pavement will be somewhat equal to the static load. However, in the case of acceleration and braking, it may not be the condition, because if you see in this case, so say for instance, I am taking a 2-axle truck. So sorry, the representation here is of a car. So consider this as a 2-axle truck. So the front axle is a single axle single wheel and the rear axle is a single axle dual wheel. So during acceleration, what happens? What happens is when due to inertia, the loads will be transferred from the front axle to the rear axle. However, in the case of braking, what happens? The loads due to inertia, the loads will be transferred from the rear axle to the front axle. So in that case, what happens? More loads in the case of braking, more loads will be transferred from the rear axle to the front axle, which is a single axle, single wheel. Compared to acceleration, now braking is found to be more critical in the case of load transfer from tire to the pavement. That is why for my topic, I have chosen braking as the critical maneuver in the load transfer from tire to the pavement. And again, there are different ways. If you see the vehicle maneuver, if you are going in a straight road such, the load transfer will be in a different manner. However, if you take a vertical curve and a horizontal curve, again, acceleration, braking, and all are happening, which is like a combined formulation. If it is happening, the load transfer will be very much different. So all these things we need to consider while designing the pavement. At least we need to know how much the load that is transferred from the tire to the pavement. Then the well-known thing is the road roughness. Road roughness also causes differential loads that are transferred from the tire to the pavement. And the third thing is vehicle suspension system. So how to get this kind of loads that are transferred from the tire to the pavement? That is one question actually. So we cannot collect it directly from the field, either using a static load pressure pad or using a weigh in motion system. Even though a weigh in motion system can somewhat capture the vehicle suspension system's effect, but still we cannot capture the influence of vehicle maneuvers as well as road roughness that influence the load transfer. So the researchers use vehicle dynamic softwares to simulate the static loads, using static loads, the dynamic loads, for knowing how much is the load transfer from the tire to the pavement. Now, let me tell you how much or how the variability will be for a static and a dynamic load. So when the vehicle is static, which means we have a constant load or a non-fluctuating load over the time. However, when the vehicle is moving, it will be in a fluctuation model. I am not telling always it will be greater than the static load, but at times it will be greater than the static load. And again, why is it varying? This is due to inertial force, as I discussed before. Now, how to perform the real-time dynamic load data collection? So, as I mentioned, we should use some kind of softwares to simulate these loads, and we can see some of the works that are carried out in this area. So, especially the acceleration and braking, very few studies have been carried out. That is basically they were associated with the vehicle dynamics perspective they have carried out. And I saw one work, it is like Nani et al. In 2006. And for rod roughness, we have several studies. And so this is the background of the work, actually, from where I started my work. So this was the background I got while I started my work. And then coming to the reliability part, if we get the loads that are transferred from the tire to the pavement, how to estimate the reliability of such loads? That is another concern. So basically, we have in the payment design, we have for estimating the allowable number of lot repetitions, or for payment design, we have a mechanistic part and an empirical part. So we can actually estimate the critical strains in the mechanistic part. We can use them in the distress transfer functions in the empirical part, and then we can calculate the allowable number of lot repetitions. And what reliability is? Probability of the allowable number of lot repetitions greater than the actual number of lot repetitions. So in the reliability part, what we need to consider here is when there is a variability in the lots that are transferred from the tire to the pavement, how to account it, or how the reliability value changes. So that we need to see. So that is what I have done as part of my research work. And we have some studies that considers the variability in the material properties, say the layer thickness, the layer modulus variation. If they are changing, how it influences the reliability, we have work. But how the variability in the lots that are transferred from the tire to the pavement varies, then how to estimate the reliability? We were not having much solutions to this problem. So this is what I took as my research problem for my PhD work, and I am showing you that work here. And now coming to the braking maneuver. So before coming to the braking simulation and all, I am just taking this as an opportunity to just tell you what happens during braking. So what happens during braking is, once the vehicle is freely moving means it is not under acceleration or braking. What happens? The velocity, the longitudinal velocity will be equal to the angular velocity. So in that case, the parameter wheel slip, which is the expression is shown here, will be equal to 0, right? V minus r omega is 0 because both are equal. Now, there is a mu lambda curve. Mu is nothing but the coefficient of friction versus lambda is nothing but the wheel slip. So this is a important curve in the vehicle dynamics part. So what mu lambda curve shows is how wheel slipping happens and how it leads to wheel locking condition. So here we can see that in the free rolling condition, where there is no braking or acceleration or anything, it is 0, right? Wheel slip is 0, so this is 0. However, when the coefficient of friction increases, that is when the braking force increases, the slip value also increases as the r omega becomes lesser than v omega v, and then the curve goes like this. And if it reaches this peak friction point, then this peak friction point it reaches means it is the critical slip case, And if it reaches this position and any disturbance or any undulations here can directly throw it to the next side. So which is like it directly leads to the wheel locking condition. So this is all about the mu lambda curve, where the peak frictional value reduces to the intermittent sliding friction value and fully sliding friction value reaches when there is fully locking condition. So this is all about how the wheel locks happen. And I'm showing the free body diagram of a vehicle, and then showing the vehicle dynamics model associated with this. So FZFA refers to the front axle vertical load, and FZRA refers to the rear axle vertical load. So the first component in both shows the static component, and the next is the dynamic component. So this is in the case of braking, where the dynamic component is being subtracted from the rear axle load and is being transferred to the front axle load, which you can see here in this using this vehicle dynamics model. Now coming to the braking simulation. So one of the unique feature of my study was to use a hardware in loop setup to simulate the braking condition. So for this, I used a vehicle dynamics software known as TruckMaker. So you can see in this setup, the TruckMaker is installed in the system and it is integrated with this hardware in loop setup. So this hardware in loop setup has, so if you see, these are real brake chambers of the front and rear axle, and there is a driver module where we can apply the brakes, acceleration, and all such things here. So I used this setup to simulate braking for my study. And the TruckMaker software has three modules mainly. There is a pavement module, there is a driver module, and there is also a vehicle module. So now coming to the test metrics that I have formulated for my research was, so I took three loading conditions from an axle load survey. So they are static loads of 2 axial trucks I took, and I fitted it with probability density functions, and I took representative unladen, laden, and overloaded vehicle from them. And these are the gross vehicle weights of each of the trucks. And you can see the legal load limit I took as per the old conventional legal load limit. And these are the trucks I used. The same truck, 2-axial truck with a single axle single wheel in the front and a single axle dual wheel in the rear, but the loading condition alone I varied. And the wheelbase of that truck is 4.2 meter. And again, the braking condition, so the speeds I applied were 30 kilometer per hour, 50 kilometer per hour, and 80 kilometer per hour. So to make it clear, so how my driver maneuver was, I accelerated the truck to a constant speed, constant desired speeds, each of these speeds, and then once upon reaching 1000 meters, I applied brakes. So what all are the different brakes I applied? So I applied slow braking, mid braking, and panic braking. So slow means it is nothing but the trucks were, so it is like a daily condition what I was actually thinking in the case. So if we see a truck or some obstacle far ahead and we know that we need to apply the brake, so in that case, so we'll be applying a 10%. So in order to make that uniformity, I am taking it as 10% as the slow braking condition. So the brakes will be applied very slowly. That is, the brake pedal will be applied only 10%. And finally, it will be going to stationary also. And then the mid braking means it is like in between a panic braking and a slow braking condition. So it is like we have seen the obstacle, but we need to apply a little more brake. which is like greater than a slow braking. So that is the intermediate braking, which I termed as mid braking condition. And now a panic braking condition in which it is like a sudden brake. So it is like 100% brake I have applied. So and again, now coming to the road profile. So there are 3 brake applications, 3 speeds, 3 loading conditions, and I took 3 road profiles as well. So these road profiles I generated in MATLAB using the ISO road profile, ISO 8608, this road profile conditions. So I'll be explaining it in the next slide. So here, as a total 81 simulations I carried out in TruckMaker for simulating the dynamic loads during braking maneuver. So these are the rod profiles, a glance of a rod profile that I have simulated in MATLAB. So I used power spectral density approach suggested by Tian et al. You can see there are 3 rod profiles, that is A, B, and C. A is nothing but it is a good rod which corresponds to IRI of 1.75. Similarly, B corresponds to 4.31. C is a poor rod, it's like 8.62 meter per kilometer. So these are the equations associated with this generating the rod profiles in MATLAB. So this rod profile I input in the pavement module. So similarly, the gross vehicle weights I input in the the vehicle module, and these brakes and speeds I input in the driver module. So these were the input parameters that I have considered for my study. And now coming to the results. So after the application of the brake, how the mu lambda curve varies. So whatever I have shown before is a typical mu lambda curve. So this is what I got from my simulation. So this is for the front axle, this is for the rear axle. So you can see that this is in the case of an unladen truck, when the truck was moved at each of the speeds, even it is 30, 50 or 80 kilometer per hour. And when panic braking was applied, the unladen truck wheels got locked. That you can see from this mu lambda curve. It has passed this critical point and it has moved to this wheel locking condition. However, in the case of laden and overloaded truck, it has not reached this critical mu condition, that is the coefficient of friction condition. It was in and around this region. I did not show the laden condition, but laden also the similar as overloaded I got. So even both wheels of the unladen truck locked. And why is it locking for an unladen truck? However, for overloaded and a laden truck, it is not locking. So that is one question here. So it is because for an unladen truck, if you look at its weights, the front axle load and the rear axle load, mostly since it is unladen, the rear axle vertical loads are very less. So once the braking loads, once braking starts, compared to overloaded truck, the mu increases. Mu increases at a very fast rate compared to the overloaded truck. So that is why in the case of unladen truck, you can see a wheel locking. As well as in the case of overloaded, you may not be seeing a wheel locking condition. So now, what is the after effect of this wheel locking? So wheel locking can lead to the steering, the control of the vehicle will be lost, and it can lead to accident, and also it can lead to different loads, a different kind of loads, or a different pattern in which the load that is transferred from the tire to the pavement will be different. In the case of wheel locking, that we can see as that I can show you here. So now, again, in the case of wheel locking, front or rear, which wheel locks first? So that is one insight I got from this one, this analysis. So which wheel locks first? The rear wheels lock first compared to front wheels. So why is it so again? The rear wheel locks compared to front locks. Maybe it not maybe it is because the vertical load from the rear axle is transferred to the front axle. So again, the rear axle FZ is like getting smaller and smaller compared to the front axle. So rear wheel locks first compared to the front wheel. Now, the deceleration plot in the case of an unladen truck where the wheel locking happens is shown here. So you can see that at 1000 meters, the brakes are applied, and you can see the deceleration values here. And at some point, it has again increased again, means that the deceleration value is decreased, and then it is reaching a stationary condition. However, in the case of overloaded truck, since that wheel locking is not happening, you can see that how the deceleration plot looks. So no such bumping effect or some, so that decrease in the deceleration value you cannot see. And now coming to the loads that are transferred from the tire to the pavement during panic braking maneuver. So this is in the case of an overloaded truck where the truck was traveling at an 80 km/h and panic braking was applied. This is the loads that are transferred from the front axle, and this is the rear axle. So you can see that there is a load transfer from the rear axle to the front axle. You can see from static loads, it is being reduced, which is gained in front axle. From static load, it has increased. So you can see that for profile, so these are for different profiles I have plotted. So for profile C, compared to the static load, it has increased 1.8 times, then 1.7 times for profile B, and 1.5 times for profile A. So so you can see how much the loads that are transferred. The significance of the load transfer from tire to the pavement during braking can be seen here. And now, as a comparison, I'm just showing for each of the truck the maximum loads that are transferred from the tire to the pavement, both horizontal as well as vertical loads I am showing here. So this is for unladen truck. The static load is, this is for front axle, okay, because the load is transferred from the rear axle to the front axle. So I am considering the front axle here. So the static load is 46.30 kilonewton, and the dynamic load, the respective dynamic load is found to be this. Here you can see for a laden truck how much it is, for overloaded truck also how much it is. And again, the longitudinal loads that are transferred from the tire to the pavement during braking, the maximum loads were found to be nearly, for all the trucks, it was found to be almost similar, that is 24 kilonewton. So this is the inference that I got from the braking maneuver. So I could see the horizontal, and I could get the horizontal and the longitudinal load transfer from the tire to the pavement, especially during the panic braking maneuver. Then I was able to study the mu lambda curves, the wheel slipping, how the wheels got locked, and all such things. And now again, in the case of panic braking, it was identified that the laden and overloaded trucks, they are safe during panic braking, at least in the case of wheel locking condition. Now we got the loads. Then how we can consider this variability in the loads in the estimation of reliability. So we are going there now. So for the estimation of reliability, I have formulated one procedure. So as you know that even the variability in the material property, there is variability in the material property or property along the pavement, and also there is variability in the loads that are transferred from the tire to the pavement. So in this, I have considered the variability in the material property as well as the variability in the loads that are transferred from tire to the pavement during braking maneuver. So this is a typical pavement cross section. I took it from the IRC 37. So, and what I did was the lower and upper limits of the material parameters, I took it from the IRC 37, and I assumed some mean and coefficient of variation values for these material properties from one of the research, and using the Monte Carlo simulations, I generated random numbers for each of the material properties. I assumed it as a normal distribution, and I generated all these variabilities in the material properties, and then using RSM models. So here a huge amount of work was carried out here to generate RSM models and all. So they I automated the IIT Pave with the MATLAB, and then I was able to generate RSM models for each of the braking loads. I will show you in the next slide for which all loads I have simulated the RSM models. So using the RSM models, the strains were estimated, and then using the distress transfer functions, again the distribution of strain, distribution of this allowable number of load repetitions were estimated, and then these were fitted using again suitable distributions, and finally its reliability was estimated. So this is the entire framework that I have followed. So these are the loads that I took from the truck maker simulation. So I consider as the static load, which is like from the static load survey, and these are the maximum front axle loads that I took from the braking simulation. So for unladen, laden, and overloaded, in total I have 12 loads. So for both epsilon T and epsilon V critical strains, I have formulated in total 24 RSM models, and using this only the rest of the procedure was done. And now this is a strain distribution diagram which I have plotted for considering the other parameters constant. So here it is the asphalt layer material properties alone I have varied, keeping the granular layer material properties constant, and so this is how the strain distribution I got from the RSM model, and using the distress transfer functions, I calculated the number of load repetitions to failure. So this is the tensile strain plot. You can see that if we consider static load for the estimation of strains, this black thing is the strain profile. However, if we consider other braking conditions, see how much it is varying. So almost 2 times and all the strain distribution is varying. And so this is for an overloaded truck I am showing here. And now this is the distribution of NF using the distribution of strains. So you can see this is for a laden truck for static load. This is how the number of load repetitions to failure varies. And slow moving bid and panic braking, you can see how the NF value varies. And from this only, for each of the loaded truck, I have considered different small n values, actual number of load repetitions, because this should fall within the upper and lower limits of each of these NF values. So you can see unladen, laden, and overloaded, I have considered different n values. And finally, finally these are the reliability values. When a static load is being considered, these are the reliability values I got for each of the loading conditions of the truck. And again, for when slow braking is considered, this is the reliability values that I got. When mid braking is considered, it is lesser. And when it comes to panic braking, I'm not showing because the overloaded truck I was not able to get, because it was like very close to zero, the distribution. So I omitted this panic braking condition here. So from for the reliability aspect, I am considering only slow, static, slow, and mid, and I'll be comparing it. So now there is a problem here. You will be thinking, I am telling that always the loads will be subjected to so either slow braking or mid braking or static and all. But we don't have the data on percentage of braking, how much vehicles are braking. As of now, I did not get any data related to that. So in that case, what I did was I did a sensitivity analysis. So what I did is I consider 40% of the, so 40, 60, like that I varied. I'm just showing how the sensitivity analysis was carried out. So 40% I considered static trucks are there. Rest of the 60% slow braking trucks are there. So in that case, how the reliability value changes. So like that I computed, and this is in a nutshell, I can show it for a laden truck how it varies. So if I consider a laden truck, if only if we consider static load for computing the reliability, then I can get it as 99.85%. But when I consider that the static load is combined with a slow braking 60-40 combination, then the reliability value reduces to 92.6%. And then if it is a mid and a static load combination, then it again reduces to 58.48%. So, so from the study, this is what I am giving as a message. So this is how the reliability value will change if there is a variability in the load that is transferred from the tire to the pavement, if we consider the load variation. And now the major findings. So from the braking simulation, whatever I have showed, so this is the static load, means this is how the dynamic load maximum values look like. And again, there is a longitudinal load that is transferred. And these are the mu lambda curves and associated slip, wheel locking condition and all I was able to study. And again, this is a preliminary study. There are a lot of scopes for the study. There are, like, we need to explore this area a lot. So this is what I showed you before. This is how the reliability value changes for different combinations of braking. And now, why the novelty of the study is like I was able to do it for a 2-axle truck, just a 2-axle truck in a straight road section. You can use it for other vehicle maneuver, not vehicle maneuvers, other type of road stretches, kind like vertical curves or horizontal curves or U-turns at intersections and all such things. And you can see how the load that is varying. And this is what the comment I got for while publishing this paper. So the reviewer mentioned that it can be used as a what to say, it is a model for other projects to estimate the loads transferred for other configuration of trucks. And again, the reliability framework that I have formulated, we can use the same framework for other trucks configuration or other loading condition or other road profiles or other road variations and all. We can use the same framework, and then we can estimate the reliability. And these are the publications associated with the current the work that I have showed. So I have done so I have 2 journal papers and 1 conference paper. So in this conference paper, I have carried out the track acceleration as well. But since the acceleration manual was not giving that much of load variation, it was giving load, but the intensity was not that high as what I got for braking. So I focused on braking maneuver for the estimation of reliability. And now, thank you for listening to my presentation.
That was an informative session. Thank you, ma'am. Now the forum is open for discussion.
Hi, this is Shijit. Can
Hi,
you hear
sir.
me?
Yes, sir.
Yeah, I have small questions.
Okay.
Actually, my question is like our roads is designed based on the IRC 37 for the
Yes.
low traffic and high traffic and everything. So
Yes.
according to you and your studies, is our roads are over designed or under designed?
Sir, it's not the question of over-designed and under-designed, sir. So it is like we are considering static load for estimation of reliability and for all the calculations. So what my point here is, when there is a variability, how the loads are transferred. So over-designed and under-designed, um, uh, maybe it's like static load alone is considered. Then I don't know, sir. Actually, we need to compare it. As I showed you the reliability values, right, in the slide. So this is when we consider it as a static load. So if I say that it is over designed, no, it is under designed, then I don't know, sir. So it is actually like this is the condition we need to. So I am not telling that we need to use only the braking loads for design. Then it will be like an over designed conditions.
Okay. No, at least for the junctions, the braking action will be more, right?
Yeah,
So
junctions. That is
that
my
area,
main
how
point.
we need to consider whether the material property has to increase for the, especially for the junctions. Like that way, I just, yeah.
Yes, sir. Actually, in the junctions, we don't have the how much percentage of the vehicles are braking, such kind of things. We don't have the data. So if we have the data and we have an idea that this much percentage is braking and this much load we need to consider as extra or something, that area alone we can give a different material there, sir, because usually we can see shovel, shoving and all such things happening in the intersection areas, right? Especially due to this braking maneuver. And even in the case of U-turns also, you can see always that area. And okay, then in the case of vertical curves, the down area and the ones which are like hitting from the, like once it is from the vertical curve, when it is moving downwards, that area and all those areas we need to concentrate, I guess, sir.
Okay, thank you.
Thank you.
Thompson.
Hello, sir.
Samson sir is there.
Oh,
Sir,
okay,
will you
sir.
please
Okay, sir.
correct, sir. Samson sir.
Audible?
Yes, sir,
Hello?
you're audible, sir. Yes, I'm sorry, you're audible, sir. I think sir has some network issue. Meanwhile, I have a question. So do you think that, like, for example, if the locations where we are expecting this kind of braking, do we have to consider any other parameters in the design? Or do you think like in such locations, do we have to go with a better mixture? Any comment on that?
Maybe a better mixture will do good, I guess, sir. Because rather than that, we can only say that this much of load is coming, and this is the reliability. If we for this location or for this raw traffic that is coming to the pavement, I mean, flying on the pavement. So maybe the better mix is the only option, I guess. And even for the uniformity in thickness, I don't think that will be practically possible to give a high thickness there alone and all such things.
Okay.
My only point here is we need to consider this while designing. And so this much of variation is there in the loads that are transferred from that to the pavement. And this is how it affects the reliability.
Okay, thank you.
Okay.
Sonia, I think I am audible now.
Yes, sir. Sounds
Okay.
good.
Yeah, good. A good presentation. Congratulations to Donia as well as Dr. Murali for a
Okay,
wonderful.
thank you, sir.
Okay, so a couple of questions. So one is you have simulated the situation, am I right?
Yes, sir.
And you have prepared like the assembly there in the lab also, no?
That setup is actually there as part of engineering design department. They are like they are dealing with this brakes and all such things. So that setup is already there, sir.
Okay. Now my question is like suppose if I wanted to, I've seen that one. I wanted to do that one in the field. Whether we should go with a like test track or something like that, or what is that you suggest?
Sir, test track will be good, sir. Actually, I just saw in one study alone in US somewhere they have done a test, they have constructed one test track, and this is mainly related to the vehicle dynamics perspective. In payment side, they have not done. So what they did is, one particular truck alone, one driver sitting, he was applying a different kinds of braking. And with some sensors, they were able to get the load, but that one study alone I saw. But again, it is like a driver dependent, driver behavior is there, will be involved in that one.
Okay, now maybe in the real like the field, this one probably you will get multiple combinations of the vehicle axle, then the loading conditions.
Yes, sir. Yes, sir. Definitely, sir.
Okay, and or
yes, sir.
maybe the driver behavior and the driver vehicle and the payment combination, all these matrices are to be considered. Am I right?
Yes, sir. Yes, sir. Actually, this one itself, like it took like 81 cases, and if we consider all such things, then it will be a huge work. So this is like a starting work, I guess, from our side related to this braking and load simulation and all such things.
Okay, okay.
It will be really good if we can see some test tracks and all such things.
That's what
We are developing it.
Maybe Murali can get some funding from ministry or from some international funding and ask for like the test track. So there is many
applications we can do.
Do that.
If we can do a test track, means even material property we can change, and then we can see how the braking and all such things.
Okay. Then this combination, static, slow, mid, and panic conditions and all. How do you derive those like the situations?
Sir, actually, this is like a sensitivity analysis I did, because everyone knows that all the vehicle will not be braking or and all such things. So I just wanted to show that if this is the case, this is how the reliability value will change. So this is how I formulated it, sir. So, so like if I consider like 100 trucks, 40 trucks, like simulation, I reran the Monte Carlo simulations to get a 40% static load condition, then a 60% slow braking condition, then I clubbed together, and here actually luckily only I got it as again a normal distribution. Otherwise this case would have been again some other reliability procedure I will have to do. But for a few cases like this, I was able to get the like to estimate the reliability. Like this, I was able to generate the value.
Okay, very good. And last but one slide, that is that what can be the scope of your the continuation of this
novelty. Yes, sir. Yes, sir. Yes, sir.
This is something great. Like probably you can maybe a dozen PhD we can produce.
Yes, sir. That is what I was telling, sir. I just created the road profile for a straight section. We can always create a road profile for a vertical curve, horizontal curve, and all such things. Again, with a different combination of vehicle types and different, as you told, sir, if it is a test track, then driver behavior we can include, and all these things we can do, sir. And again, that is one work, and again, estimation of reliability. Again, some constraints will come as we are considering all these things. So that is again another work, sir. Like that, different works we can do from this.
No, maybe one thing probably we can do that one that you probably discuss with the Murali also. Now that new highways are coming up, when new highways are coming up, when probably with the ministry, MRTH and NHAE, we can identify some like these combinations, and then during the construction itself, probably we will think of installing the sensors.
Yes, sir. Actually, we need to get data of how much the vehicles are braking. At least this much percentage of the vehicles are braking. At least one intersection study will serve, sir, for that one.
Correct. Yeah. But I remember that you have presented long back, you have shown some the percentage of the axle combinations, and that was your MS work or what?
No, sir, that is one of my objectives, sir. I actually did
right. I remember that when you were presenting that axle load combinations and all, no?
Yes, sir. Yes, sir.
Okay.
I actually carried out one axle load survey for that objective. And
Ah,
then I used extreme value distributions to capture the influence of overloaded trucks and how we
okay.
can use it in estimation of MSA, ESI, ISAL, and all such things. This is my another part of the work, sir.
Okay,
my
okay.
PhD.
I know that, and you are not revealing many things to the audience. I know that.
Not revealing, sir. I did not get it.
Yeah, okay, okay. That's okay. That's okay. It's only a for example. Anyway, good work, and you are still continuing the project, no?
I will be continuing
Ah.
for some time now. I am planning to shift, and I am like in between, sir.
You're planning to shift to Bangalore, huh?
Not Bangalore, sir, to Coimbatore.
Coimbatore. Ah, yeah, that's what Murali told me sometime. Okay,
Mhm.
good. All the best.
Thank you, sir.
Fine. And thanks to Anila also for introducing Donia.
She is my senior, sir, in MTech.
Okay, okay, fine. But okay, Gautam only will invited you, huh?
Both contacted me, sir.
Contact
Okay.
for this one.
Okay, okay. And they were very particular that lesson, Donia should present only after I leave NATPAC. That's it.
No, sir, I did not get it.
Okay, okay, fine, fine,
Okay.
fine.
Would anyone like to add any comments or ask any more questions on this topic? Now, may I call upon Srimati Ardra S. Krishna, Junior Scientist, to propose the vote of thanks.
Dear one and all, on behalf of NATPAC, I would like to extend my heartfelt gratitude to each one of you for joining us today for this insightful technical talk on the topic Influence of Braking Manoeuvres on the Reliability of Bituminous Pavements, a subject that holds significant importance in the field of transportation engineering and pavement design. We extend our sincere thanks to Dr. Donia Savio for dedicating your time and sharing your valuable knowledge with us. Your contribution to the Transpedia Research Talk series has been invaluable, and we look forward to future engagements where we can continue to learn and grow together. I would like to extend my gratitude to our director, section heads, and the organizing team for their kind support in arranging this program. Also, we would like to thank all the attendees for their participation. Special mention to our former director, Dr. Samson Matthew, for your valuable presence and interaction during the talk. Your engagement has made this session vibrant and interactive. Once again, thank you, Dr. Donia, for your exceptional contribution. We look forward to many more such enlightening sessions in the future. Thank you all and have a great day ahead.
Thank you so much for inviting me for this talk. Actually, firstly, I should say that because I got a platform to explain my research work, and thank you audience for patiently listening to me for about like 45 minutes. Thank you so much. Shall I leave now?
Yeah, thank you so much. The meeting
Okay,
is over.
thank you.
Thank you.
Okay, thank you.